So we've left our previous stop at the overlook on Chilhowee Mountain. We went down into the city of Jacksonville and have now moved one ridge, or one large set of ridges, to the east. There's a valley in between called White Plains. And if you take the stratigraphy over there, you'll see a full section of the lowest Cambrian, which is the Chilhowee, and then you'll go up into what's called the Shady Dolomite and the Rome Formation and the Conasauga Formation. If you keep coming east, you'll cross a fault and go right back into the Chilhowee. And that's what these are. These are the Chilhowee quartzites. They're identical to the rocks on Chilhowee Mountain. This is Duggar Mountain, and it's a series of thrust sheets that replicates these Chilhowee Cambrian rocks over and over and over again. You're looking at this one single sequence here. The ridge across there, that is the continuation of that. And if you look on a map, you'll just see several of these ridges. Those are all internally thrust faulted against each other and replicated that stratigraphy over and over again. And what's really cool, though, is that the fault on the east side goes under this stack of thrust sheets and then comes back up on the west side, right? So it's underneath the whole thing. And so our interpretation, and this is the interpretation of a master student that mapped this a few years ago, Derek Spurgeon, is that this sequence was internally deformed, thrust faulted, and then folded. And so we have at least 3 different deformation events that are all taking place in there. Now, you can thrust fault everything together and then transport it as part of a duplex as one single event. And then folding is a distinct separate event. By the way, there's evidence at this location for faulting. There's a fault breccia right there. And if you look back here, there's this hole. This is part of several mines up and down the hill that were iron mines. The iron is the fluid that fills in the matrix of the fault breccias. And this is one you can see right there. There's more evidence for the internal faulting. But you'll see that all up and down this valley. Lots of internal deformation, but then also the fault that bounds the whole thing folds or is folded entirely. So when we start thinking about timing, we have helium thermochronology from several different spots here in the Chilhowee, and they all indicate the earliest Pennsylvanian, but back to maybe even the Devonian time scales for the uplift and cooling of these rocks. Now, that's not compatible with these rocks being deposited and then depositing more and more Paleozoic rocks on top and then deforming it, which is the traditional idea of how you deform all the rocks in the Alabama Valley and Ridge. But that is compatible with you deposit your Cambrian and your Ordovician sequence, and then sometime after that, you start deforming those, specifically here and uplifting these rocks, perhaps in the late Devonian into the Mississippian. These rocks are uplifted, and then that is coeval with the arrival of clastic sediment in the basin to the northwest. That would be the Black Warrior Basin. The Mississippian Hartselle Sandstone is one of those clastic units. Even the Pottsville Formation is more clastic material that theoretically could have come from these highlands that are being uplifted prior to the Alleghanian. Now, if we look at the uranium, lead, zircon spectra of both, these are perfectly compatible and can be modeled to fit a idea where these are uplifted, they're eroded, and then deposited in the basin. And so that is our interpretation, that it is compatible with uplift of these rocks in the Devonian to Mississippian as this pre-Alleghanian fold and thrust belt. And then you erode this, transport it into the basin, and then you deform the entire sequence in a second Alleghanian event and reactivate many of these structures. Yeah? Yeah. I'm just looking, there's slickens right here. Mm-hmm. It's just all over the place. Fault breccias, slickens.
But you're right, it's low grade because I can still see faint cross bedding here.
Yeah, the primary sed structures are still present. You can still see cross bedding when we get over to Chilhowee, you know? Yeah. Yep. So, I mean, okay. That's a 5-minute stop. We cool with that?